Hello everyone, welcome to my YouTube channel. So in this video, let's solve one of the most popular lead code problem, that is group anagrams. Okay, so here let's understand what exactly is the ask. Here, given an array of strings strs, group the anagrams together, you can return the answer in any order. So what they are saying is like they are given a array of strings. Okay, they gave us an array of strings and we need to group the anagrams together. That means we need to find what are all the anagrams and we group them and we return those anagrams. This can be of any order. That means in this example, so I can return this 8 et in first place irrespective of any order. Okay, so let's understand what exactly is the anagram is. Okay, so so the problem which we are solving is group anagrams, right? So when we see there is a word anagram, right? What exactly is the anagram? So here anagram is like a string or bunch of strings have similar or same, we can say same character frequencies. So what exactly it is? Let's say there is a word 8, there is a word eat, there is a word tea. Okay, so here observe with this, like how many characters, like here when we separate it, like let's say a e t. Okay, how many a's are present? There is one, right? And how many t's? It is one. And how many e? It is one. So actually I wrote it in the alphabetical like order, so it starts with a, then e, then t, right? So that's why for the example. And when it comes to eat also, how many e's are one, and then a is one, and then t is one. And for t also, t we have one, e we have one, and a we have one, right? One time occurrence actually. So observe these, whatever the characters a string, one string have, similar character should be present in the other string, but it can be present in any order, right? So there we call it as, those we call it as actually the anagrams. Okay, so that means here this is what the frequencies are. That means how many times these characters occurs. Okay, that's what the anagram means. So here in the question, what exactly they are saying is like, so they gave us a string strs, which is of uh, an array of strings, which has this eat, which has this 8, which has a word tan, and then nat, and then t, and then some mm, some buy or something. Okay, so here this is the array that we have. Now how we can be able to group this, like how we can be able to find this particular string is an anagram of this particular string, right? So how we can be able to solve this problem? So one way I could think of is like, say consider it as a brute force or what. So every time I will start with the starting index first element. Okay, I will start here with eat and I will check all the other elements, so all the other strings. Okay, actually to find is there any anagram of this eat. Okay, but How we can be able to find? Observe. So in the scenarios, if we observe eat, ate, tea in the above example, right? Whatever we said, all these are anagrams, right? But when we observe, when we do sorting, okay, sorting, what we will get? We will get AET, right? For this we will get AET, for this we will get AET, for this also we will get AET. So if these sorted strings are similar, then we can say that these are all anagrams, right? So that's why if I will start by picking up a string, okay, and I sort it. That means here AET, right? After sorting this first one, after picking this first one, I will sort it. Then for every character, that means let's say if it is index I, for index I plus 1 to till the last element, I will check everywhere that by considering every other string, I will sort it and I will compare it with this particular string, right? If both are present, then I will make them as a group and return it. Clear? So this is one way we could think of, okay? And observe, guys, so while writing the code, this is one way, right? As I said, so here if I start here, let's say eat, right? And 8, when sorted, 8 is also fine, right? Because eat, 8 both are similar anagrams. Then we come to tan is not an anagram of it. Then nat is also not an anagram of it. Then t, we found t is also an anagram of it. So I will add this 8t and it will check by also, okay, but it is not an anagram. After the completion of this, we will iterate from the first element to till the last element, right, to find the anagrams. So do we need to jump into the next string? I have to jump into next string, right? But observe, this string is already found its anagram, right? Then why? I don't need to check this again, right? So here while solving, we used to consider something like a visited array, a boolean array, actually not exactly visited, just for the namesake it is, but let's take it as a boolean array. And visited is because it's like I saw this, I visit this, so that's why I just name it as visitor. And when you solve graphs and also, this visitor is mostly used, so that's why so that's why we will take this boolean array and we'll track, okay, whether if I check this or not. If I check this, then I will make it as 1 in the array, and for every time while checking, I will check this boolean array also, whether this visited value is, so whatever the value is, 1 or not, okay. This is one way. So but observe, what could be the time and space complexity here? Time complexity and let's say time complexity and space complexity, okay. So what could be the time and space complexity here? So when we see time complexity is order of n square multiplied by k log k. Why this much complexity is because I said what I will start with first element, or I will start at one place, and after that I will check all the remaining part in the array, right? So that means for every value I'm checking all the other elements, right? That means for from starting to end I will go once, right, n times, and again for checking while looping, right, for every value I will check another n, max it will go n, right. So that's why n by n, which is equal to n square for this, and for every value we are sorting it, so which requires k log k, right. So this is the time complexity. And also, as I said, we will take a boolean array, right. So that's why we are using some additional space, hence it is order of n, the space complexity. Clear? So this is pretty expensive, right, order of n square. When we say order of n square, we have to think in such a way that we need to optimize that, right. This is not feasible. Yeah, we have a solution, but we need to think of even more optimized one. So from this problem, from this, let's say from this brute force approach, what's something which we can pick or which we can optimize? Here we are picking up a string, and we will, after sorting, we will sort it, right. And after sorting I will check all the other elements and again repeating the loop. How about instead of looping it or instead of checking it again and again, if we store this value in a data structure which has the capability to store, will that work? Just think in this way. Then we will get a solution which is kind of optimal compared to brute force. That is, here it's a combination of sort and hash map. If I use this hash map to store the sorted array, okay, that means what we are doing here is like, let's say we consider this, right. So this string, so it has eat, some t, some then tan, some then nat. Okay, let's take this for now. So what happens is like, I will consider I will consider a hash map, okay, which stores a key and a value, right. So hash map is a key, right. Hash map stores key value pair, right. So I will start with this element, with this string, okay. So that means I had eat. Clear? Now after picking this up, what I will do, I will sort this AET, and I will check is there any key with AET present in the hash map or not. There isn't any, so I will add this sorted part as a key and the value as this particular thing, because we need this eat, because at the end we need to return this, not the sorted part. But why I make the sorted part as a key, it's because I know in the array if there is any anagram, if I sort that anagram of this particular eat, then that sorted should match this value, right. So that's why I make it as a key, the sorted part. So again then I will pick t, okay, t, and I check and I sort this, it will comes AET. Then I will check in the map that is there anything present. Yes, it is, there is. So then I will add this t there, okay, t. Clear? Likewise with tan and nat also. So that means here, observe what could be our time and space complexity. So the time complexity is order of n into k log k. So it's because we are not doing any kind of looping, right. So here we are reduced this n square to n This n is for I'm going from start to till end, right? So that's why I will take n and multiplied by, and for every value I'm sorting it, so which requires a log k. Clear? And then what could be the space complexity? Space is also its order of n multiplied by k. Order of n multiplied by k is because we need to store all the elements, and that elements, let's say k should be like a length of the string we consider it. So that's why a space is order of n multiplied by k. Clear? So here now, so observe, in the time complexity we see like whatever the approach that in the brute force, here in the brute force or here in this sorted approach, I mean optimal approach, we do a modification, we do like we reduced it like from order of n square to from order of n. It's well and good, but why, how about can we be able to optimize this k log k also, which instead of sorting, is there any other possible way that we can think of? So at that instant we will get into the another solution, which what happens is like here we will take the frequencies. Okay, so here I will consider a frequency array which contains an array of size 26, because 26 characters are there, right? So I mean 26 cats. So this could be the size of this particular frequency array. Clear? Now, so what should I do here? So let's take our string strs, which is like eat, and then t, and then tan, and then nat. Okay, so what we will do is like for every value, right, for every string, so initially in the above process what we do, we sorted it, right? Now what shall we do is like we will check in this frequency array which has this 26 characters, right? So I will make something like let's say a b c d e f and so on till z, right? 26 characters. So if e is present, then I will make this as 1, and a is present, then it is 1, and t is present in somewhere between, it is t that is present, else everything is false zeros, right? So I will make this as a key. So in the second approach, whatever the sort, after sorting how we make it as a key, here what we do is like we will consider a frequency array and we will find the frequency and we make it as a key. Okay, and this frequency also, how we make it, we make it like not by combining everything 1 0 0 0 1 0 something like this. We have to separate every character with some distinct different thing to differentiate, right? It's because there could be a possibility that this character occurs at 10 times or 11 times, then if we combine that, that won't be good, right? So let's say if I consider, so now one, let's say if I consider a hash, then 0, then hash, then 0, then hash, I will append for every value a hash in between. Okay, so and this I make it as a key, and like how we used here like the hash map na, so same I will use here also. right? What's the difference between difference is only the key, and we just try to optimize from whatever the sorting part that we did in the above two solutions, that is brute force one and the optimal. So here we replace that with the frequency array. Hope you guys understood, right? So now what could be the time and space complexity here? Time and space complexity. So here time complexity is order of n multiplied by k, and space complexity is order of n multiplied by k. Here you might think like why sort would be good compared to frequency, because most of the people think we know sort, we can do it, but uh, though sort here it is simple, right, but behind the scenes it requires like swappings and all, right? So that's why we had this complexity of k log k, whereas with this frequency array we can just add this values and we will go through it once, right? So that's why it's order of n multiplied by k, and for every element, right? So here n multiplied by k is because counting each string takes order of k. Clear? Because k is the length of the string. And similar with the space also. Space is also like this n is for storing. This value is for storing all the words in map list along with the keys. So this is the time and space complexity. Now let's try to solve this optimized one. Okay, so let's jump into the lead code. So what should we do in the start? We need to consider an a. So observe what we need to return. We need to return list of strings, right? So let's consider a map. Okay, in the map, what we need to store? We need to store key and the value, right? So key should be a string, and values, whatever all the values we are storing here, we observe. So for every point we will store a list, right? Let's take it as list of strings. So that's the value that we are storing. So it's a list of strings. Okay, and let's call this as a map, which is equal to new hash map. Oh, sorry, hash map, right? Now once I got the map, so I have this string array, right? Let's iterate that. For for string, let's say strs, right? Here str I considered, or let's say word. Okay, let's consider it as a word. In this I will take from the strs, right? Strs. So here what I said, I will take a frequency integer array called frequency, which is equal to new integer array of size 26. Clear? So now what we need to do, I need to find and for first initially I pick one thing, right? So here eat, I will pick eat. So I created a frequency array, right? Now I need to check every character, right? So that means I need to change this string to a character. So that means for, so here, so whatever the word we are saying, right? So for whatever the word that we got, I'm just, so okay, so for here character C in the word, So if I convert this word dot to character array, I will pick every character in the word, okay, whatever the word that we got, and so corresponding values, that means frequency of whatever the character that I got, minus if I do a character of a, this uh, uh, mm, this plus plus. So now what I need to do, I need a key, right? I need to create a key. How should we create? It should be with something like this, right? So with the hashes. So that's why, so for this what I need to do is, like, I will consider a string builder, okay, let's call it as a key, which is equal to new string builder, the year builder. So here for int, let's say here I call it as a count in the frequency. I will iterate this frequency, and what I need to do, key, whatever the key that I got, dot append this count value with, along with, I need to append the hash value, right? And hash as a character, right? So now we got the key. Now what we need to do, we need to check in the map dot, here there is a method which is called like compute if absent. Compute if absent, that means, so if it is absent, so whatever the key dot to string, so here the key that we got is a string builder, right? We need to convert it into the string. So for this value, so I will check, if it is not present, what I need to do, I need to create a new array list, right? Array list, if I found, then add this word. Clear? So if I didn't found, I will create a new array list and add the word, okay? So if I didn't, then at the last what I need to return, I need to return all the list of all the values that is present in the map, right? So that's why, let's say we will return new array list of what, map dot values. Clear? So here, if you didn't get this, right, get this part, like how we can be able to write this, else we can be able to write simply, like, as we know, if the value is not present in the map dot, like, contains key is the only thing which is familiar, right, most familiar. Then if we want to use that, let's say if map dot contains key of key, we will check this key, right? So if it is not contained in the map, then what we need to do, we need to put that in the map, right? We need to put that key along with the new array list, right? Okay, else if that is present, then what we need to do, map dot get whatever the key that we got, in that we will add this whatever the word that we got, okay? So this is also we can be able to write instead of this particular part. So let's run the solution. Cool, it works. And submit. Okay, so yes, everyone did in this way only. When you guys observe, so that's what they are doing. Yeah, they sort and make it as a key, then if put if absent, or get the value and add it. So that's it for today's video, guys. Thank you.